Hello, Algebra 2ers. We've got solving radical and rational exponent equations today, which is a mouthful, but it's pretty easy to do. So before we start with the algebraic work, I want to show you how you can do this graphically. So let me give you an example of what a radical equation would look like. If we have the square root of x minus 3 and then equals 2, and we want to solve for where they're equal, just like you can solve any equation graphically. Let the left-hand side be y1, right-hand side be y2, and then take a look at what the graph looks like. So if we go in here and do radical x minus 3, and y2, let that be 2. I'm just going to zoom 6 so that we can see our basic old screen. So the radical kind of looks like half of a sideways parabola, and then y equaling 2 is just that horizontal line right there. So if I just give myself a little sketch over here, x-axis, y-axis, there's my y1, and then to match, I'll use red here. Say here's my y2. And anytime we graph to solve, we know we're looking for the intersection point as our solution. So if I do second, trace, and then intersect, that will locate that point for us. So second, trace, intersect. This is where we get as close as we can and hit enter, enter, enter. And so I'm coming up with the intersection point of 7, 2. But this is one of those cases where we brought the y in. The y was not part of the original, so just the x would be solution.
Mama.
What? I'm recording. What?
I picked up.
Everything? Not just the junk, like the stuff on the floor and...
Oh, we just picked. No, I'm not doing it.
Right, so x is just the solution, and x equals 7 would be the solution to this particular one. Right, 2. Solve the same question algebraically, which is going to be our focus today. What we can do, let's rewrite it first, is our first step would be to get rid of the radical. We don't want to deal with the radical here. So off to the side, I'm going to write our little steps. So step 1, we're going to get the radical alone first if it's not. In this case, the radical's all by itself on the left-hand side. Then we're going to square both sides to completely eliminate the radical. So if we square the left, square the right, the radical cancels. We get x minus 3 over here. This would give us 4 on this side. And now you could end up with a bunch of different type of equations. So whatever equation you have, I'm just going to write solve equation. In this case, we're just adding 3. Ta-da! There's that x equals 7 that we expected. But the last piece of it is we do have to actually check. Whoops, sorry, trying to straighten out the picture there. We do need to check the answer. So I'm going to say answers, plural, and reject if needed. Now, the fact that we already saw the graph, so we kind of know that just x equals 7 is our answer, means that we should feel pretty good about getting that already. But the check would just be to plug back into the original. So if I plug into the original, putting 7 here, and then simplify it, this would give me radical 4, square root of that is 2, that all checks out. So I don't want to resolve, I just want to plug in and evaluate to determine if it genuinely makes the equation true or not. All right, let's try another one. So for this first one here, I'm going to give you 2 plus the square root of x plus 10, and then equals x. So let me slide on up here while you get all that written down. All right, think about those steps. We try to keep them short and sweet. First thing, get that radical alone. So in this case, we can move the 2 to the other side by subtracting it over. All right, there's step 1. Step 2, square both sides. So to square the left side, square the right side. On the left, that just becomes x plus 10. On the right, this entire entity needs to be squared. So we're going to do a little FOIL or box multiplication, whichever you prefer. So we should have x squared minus 2x and plus 4 for a total of minus 4x plus 4 when we bring it on over. Right from here, step 3, solve the equation. This time we have a quadratic equation. So with quadratics, we get everything equal to 0, and ideally, we want the x squared to be positive. It just makes things easier. So I've got x squared minus 5x minus 6 equals 0. Factor away. Think about what adds here and multiplies here. With 6, it can either be 6 and 1 or 2 and 3. With the signs, I think we're going minus 6 and plus 1, so that they'll add to negative 5, but multiply to give us negative 6. So when we solve, we get x equals 6, x equals negative 1. You can absolutely have 2 answers and they both stay, but we definitely want to check and make sure of it. So when I plug back in, I'm going all the way back to the original equation. So 6 plus 10, and then I have to plug in a 6 here. This gives us radical 16. So 2 plus 4 equals 6. Gorgeous. That first one's good to go. All right, check the second one. 2 plus, we can put negative 1 here, plus 10, and then equals negative 1. So this is going to give us the square root of 9. So 2 plus 3 is going to come down to be 5. That is not equal to negative 1. So if they're coming out unequal here, then this is an extraneous answer, meaning it's extra. It doesn't count, and we get rid of it. So our solution should just be x equals 6 for that first one there. All right, let's keep moving. We want to make sure to hit a couple different types of examples so that we feel prepared when we hit the homework. All right. Ooh, let's see, where is the top of the page? There it is. Okay. For number 2, I'm going to give you, in parentheses, x plus 6 raised to the 1/2 power minus 2x minus 4 raised to the 1/2 power equals 0. All right, this one is a great reminder of, well, what does it mean when you raise something to the 1/2 power? So anything raised to the 1/2 power is the same as taking the square root of it. And so I can rewrite this. This is the same as the square root of x plus 6 minus the square root of 2x minus 4 equals 0. All right, well, step 1 of how to solve is to get the radical alone. If I have 2 different radicals, I want to get 1 on each side. So let's add this radical on over, which means I'm going to have radical x plus 6 here. Sorry, I was getting a little lazy with my notation there. And then I'm going to have radical 2x minus 4 on the right-hand side. All right, now that the radicals are by themselves, square them. This just cancels, and that one cancels. So that's actually a really simple equation now to solve. Subtract x. At the same time, we can add that 4 on over, and we get x equals 10. All right, before we box it in, quick check. So if I plug in to the original, and we can take the original as with the 1/2 or with the radicals because those are both equivalent. We haven't done much to them. We do the square root of 10 plus 6 minus the square root of 2 times 10 minus 4. We want to show that that's equal to 0. So radical 16 minus, well, 20 minus 4, that's radical 16. Yeah, 0 equals 0. And we're good to go. All right, number 3. You know it's going to get a little different with this next one. So we have square root of x plus 2 plus 12 equals 11. All right, radical alone. Step number 1, move that 12 on over. Step number 2, square to get rid of the radical. All right, that's going to give us x plus 2 on the left. Remember, when you square a negative, it becomes positive. That gives us a 1 on the right. Subtract to solve. We get -1. And then lastly, maybe I'll squeeze my check in over here. Check. So let's put -1 in. So this will give me square root of 1, which is 1, plus 12 equals 11. Well, that doesn't make any sense. So when the only answer I get doesn't check, that means, first of all, that we have no solution. But it also means that there might have been somewhere in the problem that we could have seen this coming. And if we backtrack, it's actually in this step right here. If we stop and look at that step before we square, we had radical x plus 2 equal to -1. Whenever we take the square root of something, it should never be equal to a negative number. So if you see this somewhere in the problem, you can know right there that it's not going to work out, right? So you can actually stop your work and say no solution. So if you see a radical equal to a negative number, you can stop and say, no solution, right? Because it's never going to happen. So it's a nice little shortcut if you see that one in the homework. All right. With that being said, we've done enough with square roots. We have a couple left to talk about. The next one's a cube root. So if we do the cube root of x plus 2 plus 7 equals 5, we're going to start it the same way. In this case, get the cube root alone. So move the 7 over. And now right here, a cube root can be equal to a negative. A square root cannot. So remind yourself, a cube root can equal a negative number. All right, so this is perfectly fine. So what we're going to do then is cube both sides. So cube the left, cube the right. This gives us x plus 2, -2 cubed. So -2 times -2 times -2 is -8. And then subtract 2. We get x equals -10. All right. Just like any other problem, you do have to check. You plug right back into the original and convince yourself that we didn't make anything up and that this is good. So this comes out to be the cube root of -8, which beautifully comes out to be -2. And you're going to get 5 on both sides. We're good to go. All right. We have one last little thing to talk about before we finish the notes here. So we mentioned it earlier in a question, and I'm going to add it as a little reminder right here, right? When we have the square root of something, we knew that that's the same as raising it to the 1/2 power. So the example that we did, and I'll slide it back up here so that you can remember it, with number 2, we changed it to a square root and then squared both sides. But it would still work if we hadn't changed it to a square root, right? So if I say remember, oops, I've already said remember. Let's look at example 2, all right? It was the one like this, that x plus 6 raised to the 1/2, and then minus 2x minus 4 raised to the 1/2 equals 0. We would still move that over, but I don't have to rewrite it with a square root. Think about what happens when you square both sides here. If I square the left side and square the right side, power raised to a power, you'd multiply. So 1/2 times 2 comes out to be x plus 6 to the first, or just x plus 6 itself. And then same thing over here. Power raised to a power. This would just end up as 2x minus 4 raised to the first power. And so then you can continue the problem from there. So I'm just going to go ... The reason I bring that up, right, is that it works because 1/2 and 2 are reciprocals. When you multiply by the reciprocal, you get 1. So write yourself a big old note here that if we raise both sides of the equation to the reciprocal power, right? Because 2 is the reciprocal of 1/2. Then power raised to a power, there's a little caret notation there, right? Equals multiply the exponents, and you end up with an exponent of 1. So let's show how we can use that to our advantage with the last example of the notes. All right, we've got x squared minus 15x plus 52 raised to the 2/3 power and then equals 4. All right, rather than writing this as this thing squared and then the cube root, I don't want to do that. What I want to think of is what would be the reciprocal of 2/3? So the reciprocal of 2/3 is simply flip it over 3/2. What we're going to do here is raise both sides to the reciprocal power. So on the left, I'm going to raise it to the 3/2 power. On the right, I'm going to raise it to the 3/2 power. So remind yourself what happens. Power raised to a power, we multiply. 2/3 times 3/2 gives me x squared minus 5x plus 52, now raised to just the first power. On the right-hand side, you can grab your calculator, whatever makes this easiest. This means 4 cubed, and then take the square root. But there's nothing wrong, with just grabbing your calculator and saying 4 raised to the 3/2 power. There we go. And that'll give us 8. And so write yourself a little note that you can use your calculator here, right? Well, let's go. If this is to the first power, I can drop that 1 right off of there. So x squared minus 15x plus 52 equals 8. Now I would subtract the 8 on over. So x squared minus 15x, this is going to give us plus 44 equals 0. And now this is a little add multiply guy. What multiplies to 44 but adds to negative 15? Well, we can do 4 and 11. So minus and minus for both. So my two solutions initially look like 4 and 11. And then we would need to do a quick check. Now to check one like this, it's a little messy. So I would strongly suggest use your calculator. So I'm going to plug in 11 squared minus 15 times 11 plus 52. That thing raised to the 2/3 power, does it come out to be 4? This is where I would absolutely use my calculator. So put some parentheses, go 11 squared minus 15 times 11 plus 52, close it up, and then raise it to the 2/3 power. And look at that, it comes out perfectly to be 4. So this one checks, so we can keep that answer. And now check the other one. So plug in a 4. So it's going to be in parentheses 4 squared minus 15 times 4 plus 52. Close it up and raise it to the 2/3 power. Does that come out to equal 4? And you can do the exact same thing. So we can go 4 squared and then minus 15 times 4 plus 52. Close it up and raise it to the 2/3 power. That one also checks out. And so that's our final answer. All right. Before you click out of the video, your second question that you have to answer right here is I want to know what power would you raise both sides to solve this little equation? So if I give you 2x plus 1 raised to the 3/4 power equals 8. You don't have to solve it. I want to know what power are we raising both sides to solve it. All right. Thanks, guys.